Okay, so the last of the 4.1 notes, we talked yesterday about degrees to radians. This is just a slide we actually saw yesterday. I just started it on here. So 1 degree is 1/360th of a movement. So we're going to work on the conversion between the two. So to convert, I think we did this one too. You have 360. You don't really need to write this down. Just watch, please. We have 360 equals 2 pi radians. You are not going to write rad. You're not going to write it.
Thanks.
Okay? Now, I have seen some books when it goes back and forth and it's in doing a lot of things, they might put a capital R behind it. What do you think that means? Radians. Okay, but if there's no degree and it's an angle, it's radians. So I would divide both sides by 2 and I would get 180 equals pi. Yes? So 1 degree is pi over 180. 1 radian is 180 over pi. So for our conversion between the two, when I am going from degrees to radians, okay, you take theta. When I'm going again, degrees to radians, I take theta times pi over 180 degrees. Think about it, guys. If I want to reduce out the degree needs to be in the denominator, yes?
Yeah.
Okay. If I'm going from radian to degree, so I want to reduce out the radian, it goes where? In the denominator. So it's 180 over pi. And it's 180 degrees over pi. That is the conversion factor for converting from degrees to radians.
This is videotaping, right?
What?
This is videotaping?
Yes.
I'm not going to have these at the beginning of my notes because that's just not order.
So we went through these yesterday. We did 30. We said how many times does 30 go into 180? We said what?
You said 6.
6. And so it's pi over 6.
Yeah.
We did all of these at the bottom yesterday. You do not need to rewrite them. 4 goes into 180, 45, or 45 goes into 180 4 times, so it's pi over 4. When you get angles like 30, 45, 60, 90, 180, 360, 270, you're not going to use the formula because you're going to think about what's actually happening. Okay? The formula will take much longer to do. We're going to use the formula on angles that aren't like those. Does everyone have their conversions written down?
Yeah.
Okay. So, convert 135 into radians. 135 is an angle that we will know soon, but not right this second. So, 135, I want it into radians, so what goes in the numerator? Pi. Guys, think about science. When you want to reduce, you have railroad tracks, right?
We are bad at converting.
Well, you're going to get better. So we can reduce the degree in the degree. If I had the degrees next to each other, that would be degree squared. Does that work? Not when we're converting. Okay, 135 and 180, what goes into both?
5.
5 at least. So 135 becomes what? 227? Pi over 336? Am I reduced?
You reduce more.
I can reduce more. I can reduce out of 9, right?
Yeah.
3 pi over 4. Guys, 4. What's 4? Huh? What's 4?
It's
What's 4?
45.
45. How many 45 pieces do I have? 3. So guess what? That angle would be 1, 2, and 3. 135. And should you be able to write that pretty accurately? Because it's exactly half of a quadrant, correct?
Yeah.
So this right here is 3 pi over 4 and also 135. If you also think of it, guys, pi would be 4 pi over 4, yes? If we're thinking about 45 pieces.
Yeah.
So do I have 1 less than a whole pi? Yes. We will be doing lots of fractional math. Okay, 240 is not one of the angles you will know and love. What do I need to multiply it by?
That's 5.
Or 540, excuse me.
Pi over 180.
Pi over 180. Because we're converting 2 to radians, so radian has to go in the numerator.
Did you reduce 10 out of it?
Yes, I would definitely reduce 10 immediately. What else?
6.
Go for 9.
Can we go for 9?
Yeah.
If you do 6, you got to do 3 after.
Oh, yeah,
So
nine.
do 6, Elena.
Nice.
You do 6, we'll do 9. We'll all end up in the
Or
same place.
18.
So we get 6 over what? 2?
6 pi over 2.
Well, 6 over 2 is
3.
3. So if we would have just reduced by 18, we would have been better, but who knows their multiples of 18. Yeah. I don't know my multiples of 180, do you?
Well, I know that one.
Okay. So whatever we do, we have to get down to the same. Elena was going to reduce by 3, and that's perfectly fine. Could we have reduced by 2 for a long time?
Yeah.
Yep. It would have took you forever. But do you have to reduce?
Yeah.
Always and forever.
Somewhere.
And sometimes you can't reduce, right? What if I had 111 degrees?
Well, then you probably can't reduce.
I'd have pi over 180, right? So my answer would be 111 pi over 180. The only thing that reduced was what?
The degree.
The degrees. Okay? So, and actually I lied because of 111 does reduce by 3, doesn't it?
Well, we didn't know that.
What, 1? Okay, you guys don't know your divisibility rule for 3?
Not a 100.
Add 'em up.
As to 3, yeah, okay.
Okay, 1 plus 1 plus 1 is 3, so, and 3 definitely goes into 18, correct?
That's new.
Yup.
I've never heard of anything.
You should have.
I've never heard of that.
I've never taught that mistake.
No, you never learned it.
I've never
Okay,
Wait, what do you do for the
oh, you want to go convert it? Or what? Oh, you want it reduced?
angle?
Huh?
Do you have to draw the angle?
No. Did it say draw the angle? I think it just said convert. I just was showing you the other one was. You want to? We can.
Let's do it.
The 540?
Yeah.
Okay, so where's 540 going to be at?
What's 3 pi?
Jeez, Cam.
Okay, so it's 3 pi, yes?
Yeah. Is it,
And this is pi, and this is 2 pi. So if I go, this is 1 pi. I don't know why I drew it like that. 1 pi, 2 pi, 3 pi? Okay. Because we're just adding up pies, right?
Soon enough, we're going to get that bees keep adding up pies.
I didn't say we're eating them. We're just adding them. We're making them to sell them to other people.
But we get pies for Pi Day.
how do we do
And only if you make them.
Think about that.
Okay, so convert to degrees. What goes to the numerator?
180 degrees.
180. So 180 degrees
Over pi.
You're weird. She's being weird.
The
over pi.
The pi is reduced.
The pi's reduce. Does 11 and 180 reduce?
Maybe.
No.
Well, it was
So
111.
so then I have to do 0, 5 times is what, 6? Carry a 5 over 11 degrees. Now, can anybody guess why I put parentheses around all of it?
Because you didn't want to do the math.
So you know the differences between the
Is the degree just in the numerator?
No.
No, it's a what? On the whole thing? And I guess we could do the math. Does it go? I don't think it goes in there nicely. 11 goes into 12 how many times?
No, we don't have to. Let's not do it.
1.
No.
It may go nice.
No.
Goes into 16, 1.
be productive.
60. No. 5. And then it would just be 4, 3, 2, 1. And it would just keep going.
That's pretty cool. It's one of these.
Okay. So, what about 5? Is that radian or degrees?
Radian.
How do I know it's radian?
Because it doesn't have anything after it.
Okay, so then I multiply it still by what?
180 over pi.
180 over pi. So then that just gives me 900 pi, what? Degrees. Just because it has a pi in it doesn't mean it's radians, does it? Just because it doesn't have a pi in it doesn't mean it's not radians. So if it has a degree, it's a degree. If it doesn't have a degree, it's a radian. Are we good with this?
I want pi.
Honestly, you should bring us some pie.
No.
Why? That's the only thing I like about pasta.
Miss Poss brought us pie for pie.
Okay, I'm teaching you. Okay, so the arc length, we talked about it yesterday and I told you it would come up again. Arc length is S. So when I have my nice circle,
That's almost a perfect circle.
okay,
So cool.
so I have an angle, yes?
Yes, you do.
Okay, that angle is theta. Here, right here of the circle is known as the what? No,
Where? Oh.
From
that's
Radius.
that's the radius of the circle.
Aren't we all-
And from here to here is an arc, correct? And it is S. So theta is what?
Angle,
An angle. R is the
radius,
radius. And S is the
arc length.
arc length. S is the arc length from the initial to the terminal rays. That's what it is. That's how much movement is happening. So you have the equation of S equals R theta. And theta, you need to put in big, huge, gigantic letters is in... Wait, sorry. Wrong one. Theta is in, what do you think?
Radians.
Radians. Okay? That's where it was at. I knew it was there. Theta is in radians in this formula. S equals R theta. And yes, you need to know that. There is arc length, radius, and theta. As long as you have two of those things, can you get the other?
What?
Yes. Okay? So if you are given a theta that is not in radian, do you have to put it in radian to use this formula? Yes. This formula does not work unless theta is in what?
Radius.
Radians.
What is it at?
What is what at?
The uploading.
I don't know. I can't look. Keep refreshing. See if it pops
I
up.
have. I just did like 5 seconds ago.
Do it again.
It's ridiculous.
Okay. So again, I can move this around. What's R equal?
There you go.
Theta S, or S theta.
Nope.
Theta
Theta S.
over S.
No.
S over theta.
S over theta. Let's
I was getting there.
do our algebra right? What's theta equal?
S over R.
S over R. As we work through the book, they're going to say, ooh, you can find theta with this new formula. I put S over theta. Should be S over what?
R.
R.
You should do your
Okay.
algebra right.
Are these new formulas?
No.
No. There is one formula, and the one formula you need to remember, and the easiest one to remember is what?
S equals R times theta.
S equals R times theta. You need to know R stands for radius, theta is an angle, so S has to be the arc length, correct? As we go through here, I am not going to do this aha moment that the book does. They're like, ooh, look at this newfangled invention I got. It's not. It's just like the Pythagorean theorem
sound bitter.
is the quadratic formula, not the quadratic formula, is the distance formula. It is the equation of a circle. These things are not new. We're using them in different ways.
Feel hurt.
Am I good?
New way.
Am I good?
Do we do ACT prep in here?
We are every day.
Oh.
Okay, so a circle has a radius of 4 inches. Find the length of the arc that is intercepted by the central angle of 240 degrees.
Intercepted.
So plug it in.
So, nope. Something wrong with what I got.
What? Oh, yeah,
Well, your
radius.
theta is in degrees.
Okay, so I have S equals R theta, but theta has to be in radians. So 240 times what? No, pi over 180. You have to reduce out the degree.
Degrees reduced.
So 10 and 10, right?
Yep.
And I hope we're going with 6. Is that the biggest number?
Yep, totally. What about?
I get 4 pi over 3.
Yep.
Okay, so now that is my theta, yes?
Yep.
So S equals 4 times 4 pi over 3. And you guys need to reduce. A lot of times I'm not going to give you a calculator. So if you reduce before you multiply, is it going to make your life easier?
Mm-hmm.
Yes. Can I reduce anything here?
No.
No. So S is 16 pi over 3. And we have inches. I have to put a label, right? If I don't give you a calculator, I'm looking for an exact answer. I don't want you putting 3.14 in for pi. That doesn't exist in your world anymore. The calculators you have a pi button on it. Use it. It's right above the caret. It's like second caret is the pi. Okay, if you do an approximation, you will put pi in your calculator, not 3.14.
Will give us the wrong answer.
It won't be rounded, right? And I take off a rounding error. So, but like I said, most of the time you won't even have a calculator anyway. You're going to leave pi in your answers. The answers that we're looking for are things I want you to be able to plug it into something else and use it. And then you want it exact as you want. Okay.
Get uploaded?
Any more questions on this problem?
No, man.
Okay.
Oh, wait.
Sorry.
No, you're fine.
Are you good? Are you sure?
Yeah, I didn't get the top right part.
There it goes.
Version.
The conversion part.
The single most important part.
What are you staring at?
Still didn't figure it out yet.
Gentlemen, are you good, Elena?
I know. Yes.
You're not?
No, I was scared when you moved it.
What?
That-
Yeah, you
that
can
is
see
very
it. My
easy.
sister found my episode.
I tell you guys, you need to learn to take notes quicker.
All these circles.
Oh, you're staring at me.
I'm just telling you, you gotta learn to take notes quicker.
I need my compass.
What I did looking, you can't quit staring at me.
Okay. Bradley, can you take off your hood, please? Ethan, can you turn around, please?
Okay, I'm good.
Okay, so, sector. A sector is a region. This is the technical, guys. A sector is a portion of a circle. Yes? The pink on here is a sector. That's what a sector is. So the sector of a circle is a region bounded by 2 radii, or radius, right, of the circle and their intercepted arc. You actually have a sector here. Yes? Wouldn't that be a sector? Yeah? And you had the pink. There are 2 sectors. Pac-Man's a sector.
Pac-Man is busted.
Okay?
So we're playing Pac-Man.
Somebody else give me an example of a sector.
Military terms.
Area 51.
A pizza, after you take a pizza out of it is a sector,
I was
yes?
gonna say that, but-
Actually, a piece of pizza is a sector, yes?
So, yeah.
Okay? The pie isn't because it's a circle, but once you take a piece,
Also, the
No,
Pac-Man
like a
is
cut.
Oh, okay.
sector. It-
Give me other than food.
No.
You give us some.
What about ice cream cone?
That's food.
That's food.
That's.
Oh, it is, but like a cut piece of like a round object. Okay,
Still-
so we will do at the end of this chapter, we are going to do a sector project where you're going to find something in your world that is a circle
It is a pie.
and make a sector out of it.
A basket.
Okay? A basketball. Back there, those are actual sector projects that people have handed in before. I love Ferris wheels. They're amazing. We'll talk about the first Ferris wheel in here. His name was Ferris.
Fancy?
And so the one was a grill, and
I would think those are.
and there's a lot of stuff that goes with it. That's just the design part of it. I have pictures of ones I'll show you other than that. But sectors are all over the place. It's anything, a portion of a circle, right? So anything in your world that's a circle and a portion of it. So I'll ask you to be creative and have fun with it.
Yeah, I'm not creative.
It should be an easy test grade.
I'll be really creative.
Okay, so then area of a sector. A sector looks kind of like a what?
Pac-Man.
A sector, a slice, kind of like an angle.
What geometric shape?
A triangle.
A triangle, yes?
A pizza.
And what's the area of a triangle?
Height.
Length times
What?
length times height.
Sorry, give me a second.
Half.
So 1/2 base times height, yes?
Yeah, base.
Okay, or length times width divided by 2, whatever. It's half of a rectangle, right? So look at the area of a sector. Does it kind of make sense?
Crazy.
Okay, we got half and r squared. What's the area of a circle?
Pi r squared.
Pi r squared, yes? So it's a triangle shape in a circle, so look where the area formula comes from.
Yeah, it's just like
Half of r squared, and theta, again, has to be in what?
Radian.
Radians.
That's the area of a sector.
That is the area of a sector.
Why didn't you put a line under my circle?
Okay, so if you think about it, again, it's a triangular shape out of a circle, right? And that formula, if you look at it, makes sense then, right? 1/2 the area of a circle, and theta stands for the central angle, doesn't it? Theta is the central angle.
Yeah.
Yeah.
So it puts all those pieces in there.
It puts them in.
You have to know this formula also. I don't give it to you. Just like I would expect you to know these. I would expect you to find the area of a rectangle. I'm also expecting you to find an area of a sector. So if I know r and area, can I find theta?
Probably.
Yes. So again, can I rearrange this formula and find other pieces of it?
In many
Yeah.
ways.
Yes. Does everyone have 1/2 r squared theta written down?
Yeah.
Does everyone have down in big, huge letters? Theta is in
Radian.
radians?
Well, it's
Yeah.
Okay, so let's go back to this piece right here and use it real quick. So, area. We found S to be what?
16 pi over 3.
Over 3 inches. And theta was what?
4 pi over 3.
Oh, 4 pi over 3. I should have known that one anyway. Sorry.
Yeah, you should have.
Okay, so 1/2 r squared theta. Yes?
Yes.
So 1/2 times what?
4 squared.
4 squared is 16 times 4 pi over 3. So half of 16 is 8. So area equals 32 pi over 3 inches squared. Or square inches. Okay. That is it for us today. And that is it. So on the board, it is right on classroom, but on the board you're on the 47 through 60.
Are you saying there's